go.
Today, we'll be talking about the observer design pattern, me and Daniel. First of all, what is the observer design pattern? It's a behavioral design pattern where some object or subject maintains a list of some other objects, observers, and notifies them anytime the state changes. It's used when objects don't want to be closely linked, allowing for a clear separation between many parts of your code. It also allows for a one-to-many approach where one subject can inform many observers about changes to its state at once. Here's a few real-world examples. In game development, various game entities, subjects, such as players or enemies, might change state during gameplay. Observers, such as functions that handle rendering, physics, or AI logic, need to react to those changes accordingly. For example, when a player picks up an item, the inventory system needs to update their inventory, and the rendering system update their visuals, showing the item not to be on the ground anymore. Another example, in a social media application, we have a person being followed, the subject, and the people following them, the observers. Every time a new post is made in the subject's account, the followers want to be notified. Moving on to the participants in the observer design pattern. This includes the subject, observer, concrete subject, and concrete observer. The subject is an abstract object that maintains a list of observers and contains methods that attach, detach, and notify them of any state changes. The observer is another abstract object that defines an update method, which is called by the subject to notify the observer of any changes. The concrete subject is a class extend subject and holds a state of interest to the observers. It implements methods to get and set its state and calls the notify method whenever its state changes to update all attached observers. The concrete observer is a class that implements the observer interface and defines the update method to perform actions in response to notifications from the subject. It maintains a reference to the concrete subject to retrieve updated state information. The parts highlighted in bold show the relationship between the different parts of the design pattern, with the subject holding a list of observers to update, and the observers being interested in the state of and updated by the subject. Here we have a generic UML diagram detailing different aspects of the observer design pattern. In it, you can see the different functions of and linking between classes. The subject has functions to attach, detach, and notify observers, with the notify function calling update on every observer. The concrete object has its states and calls notify when the state is changed, and the concrete observer has an update function where it simply sets the observer state to the subject state.
So what are the pros and cons of using the observer model? The pros include that it supports loose coupling, meaning with that come modularity and reusability. If we have different subjects and observers, we can use the same ones for different parts of our project, regardless of how intertwined these two parts of the project are, they are still subject and observers. It's also easy to add or remove observers from these subjects, which makes it very good if you want to have multiple interchangeable observers. The cons of using this design pattern is that the order of the observers is undetermined in the subjects. This means that if you need to be updating these observers in a specific order, this might not work for you. It can also lead to complexity issues if it's not implemented properly. Because there's so many references and pointers from observers to subjects and subjects to observers, if something isn't handled correctly, there could be a lot of memory leaks or issues further down the line that could be hard to track. There are also a lot of computations that are now put from the observer side to the subject side. This means that if you were to have a framework such as a server and clients, like a web server, most of the computation that would have been in the client's web browser are now all put onto the server side. This could be a good thing or a bad thing, but the the case that we thought of was that if the server had to do a lot more computation, this could lead to a monetary restriction in using a lot of resources in the server. So when do you use an observer design pattern? The best cases are when you have one too many dependencies between objects, where a change in one object, which would be the subject, should trigger updates in multiple dependent objects, which are the observers. When the state of one object needs to be reflected in other objects without being tightly coupled. And when you need to dynamically manage and update the list of dependent objects, which are the observers, at runtime. This pattern allows observers to be added or removed as needed, providing flexibility in how components interact and respond to changes in the system. So when should you not use the observer design pattern? When the number of observers is very large, this can cause frequent notifications between the two, which could lead to performance bottlenecks. Going back to the example of having a web server and clients, if there's a lot of notifications coming from the servers to the clients, this could lead to performance bottlenecks and issues with using too much bandwidth. If the relationships between objects is static and unlikely to change, it doesn't make sense to use this design pattern, as there's not a lot of updates going from the subject to the object, and it might be better to just keep what you ever had before. And if the cost of maintaining the observer list outweighs the benefits of decoupling, it might be better to just keep it all not loose. So if you were to implement this design pattern, what should we do? So the first step is to clearly label the subject and observers. What data structure should be observing data from what? And then create the subject and observer interfaces from that. We want to have an attach, detach, and notify methods for the subject, and an update method for the observer. These will allow the two to communicate with each other. And then we want to make a concrete subject and concrete observer interfaces. And these are the references that the subjects and observers have to each other, which allow them to communicate effectively. So we have some sample code here now. This is two examples of the observer design pattern written in C++. On the left side, we have a very basic generic um, example with just a subject and an observer. So we see that we have the observer class first that has the update function method, sorry, and then we have the subject class with private variables being observers, a list of observers that it's going to send out the notifications to, and then the item, which is the data itself that it's sending. And then we have the attach, so we can attach the observer to the subject, detach to the opposite of that, and then notify, which updates all of the observers. Here on the right side, we have another example in C++, and this is more of a specific example in terms of a game. So we have a player, an inventory, and environment, and the player would be the subject, and the inventory and environment are the observers. So when the player is made, it's attached to the inventory and environment, which allows them to communicate. And whenever the player picks up an item, it can notify both the inventory and the environment on what happened, which allows for decoupling to be better between the player, inventory, and environment, as opposed to having one big thing. And these are our works cited. And thank you for listening.